Hello, everyone. Today, I want to talk about is the artificial neural network a reliable tool for predicting and prediction, actually in subsurface engineering. My name is Hossein Izadi, the first year PhD student in petroleum engineering from the University of Alberta. I have 10 years experiences on machine learning and machine vision applications in petroleum engineering, mining engineering, neurosciences, and handwriting recognition. I was rated one patent and published 12 journal and 10 conference papers, and I have developed six intelligent research software for the industry. Okay, let's talk about machine learning in the first slides, and I will go through the um, main point that really is artificial neural network a reliable thing in subsurface engineering or not. We have almost 8 billion people on the earth, and while we have 7 billion people on LinkedIn who are data scientists or machine learning experts or so on. And it's very interesting, and also it's very weird, really. Um, just for letting you know, guys, if you just participate in an online course in somewhere, in data scientist, you cannot turn to a data scientist. Okay, you need several years experiences in different fields, and not only working in academic side, because in at the university you are not in rush for developing a reliable intelligent system and developing something reliable and accurate for using, so for example, big data and using data analytics for engineering solutions. But in the industry, you must you must develop reliable things, because the customers and the clients will not pay you if you cannot develop such a reliable thing. And so you have to, and you must, based on my experiences, you must uh, work in the industry, in the industry, and experience many things in the industry for coming up with real and reliable results based on the challenge and problems that we have in the industry, especially in subsurface engineering. Everything is completely different. We will go through it in the next slides. Intelligent systems or intelligent solutions, it means something like making a whole workflow intelligent. Okay, a whole workflow, not only just predicting something or classifying something. It's not an intelligent system. You have to make a workflow intelligent from A to Z. Okay, you have to program the computer. When we are talking about intelligent system without programming, we are talking about nothing. Programming is the basic and the fundamental of developing an intelligent system. Programming is the basic and the first step for developing an intelligent system, because intelligent systems are something that can be used in specific problems. You know, you can find very, you cannot find some already developed code for all problems, because softwares generally softwares are developed for some general things because they are commercial, and so they have to find many customers. So the problems should be general. Everyone should face with these kinds of problem. But when you are talking about intelligent system, especially for different fields, you have to develop your own intelligence systems in your project and problem. So you have to program the computer. There is no any other software for using in your problems or projects in terms of developing intelligence system. You have to program the computer to think and act like a human expert in different conditions. You have to learn the computer to like to act and think. like a human expert in different conditions. And these different conditions must be recognized by the machine. It can be under the human expert supervision, but everything should be programmed in the machine and computer. So we are now talking about a real intelligent system or a real intelligent solution. Obviously, and of course, it's under the human expert supervision. But when we are talking about intelligent system, it should be something like these expressions. Machine learning and machine vision are about the art of talking to the computer, the art of looking at the data. It's about the philosophy of physics behind the sense of the phenomena. It's not something simple, right? It's not something simple. It's like training a baby to be superhuman. Machine learning is developing a computer with the ability of thinking like a human expert, or developing a human with the calculation speed of a computer. This is machine learning or artificial intelligence. This is the right concept. Okay, let's go through the main point. The artificial neural network is something that try to learn and uncover the relationship between inputs and their corresponding output. You guys, I'm sure that you guys know what the artificial neural network is, and I don't want to spend many time to explain the neural network. In simple word, it's an estimator or maybe a predictor. It's basically nonlinear neural network. Is basically nonlinear. Mainly a nonlinear activation function is used in artificial neural network for you know minimizing the differences between the predicted values with the measured values or real values. Okay, in this presentation, I just want to question the ability of artificial neural networks in subsurface engineering as a predictor. I'm just questioning the neural network ability. Just imagine that we want to train an ANN in well, for example, number one, based on A1, A2, A3, and A4 features as input and predict B as output in well number one. Now we want to predict B in well number two based on the trained ANN in well number one. Of course, we have the similar features in well number two, and we want to assign these features to the neural network for predicting the B value in well number two. There are two cases. If the reservoir is very homogeneous, that is far away from the reality, especially when we are working in the real world. The reservoir and subsurface is not homogeneous. The case number two is that when the reservoir is heterogeneous, that matches with the real world. If the reservoir is homogeneous, so why we are using ANN? Why we are using ANN? Why we do not use the simplest and conventional regressions to predict the values? Why we are going to Uber with a Bugatti, with a complex mathematical background of the neural network? Why we are using very something that is very complex for solving a very basic and simple problem? If it is homogeneous, just we can come up with a simple regressions for estimating and predicting the values. And if the reservoir is heterogeneous, it's another story. Let's take a look on a real example. Um, you can here see a prediction for a value, a feature in a well. We trained a neural network in well number one, for example, and use the trained neural network for prediction for predicting a feature in well number two, as the example I just noted and mentioned in the previous slides. This is the result of the prediction. We can find out that we have uh, underestimation by using the neural network. Especially now, we I have used LMAL neural network. It means that in those data that we have underestimation, it means in well number one, for A1, A2, A3, and A4, we have the results equal to B in well number one. However, in well number two, with the same inputs, we have C as a result, not B. So this is something that we call uncertainty in subsurface engineering. In another well, due to some faults or due to some shale barriers, many reasons we can just sort here, that we have different things and we have heterogeneity between these wells, because we are working in subsurface environment and we have no idea about what's going on down there. In others, I just named the data. Those data that we have underestimation, I call it data one. And in others that we do not have any underestimation and everything is okay, I named them data two. RMSE, root mean square error, for the case that we use the best structure of a neural network. I optimize the number of neurons, I optimize everything with the best structure for the both data one and data two. Just imagine that we use neural network for prediction, for B feature prediction in well number two. For the both data one and data two, the RMSE is equal to 15.24. RMSE, when we use neural network for data two, those that everything is okay and we do not have any underestimation. And when we use a simple linear regression for data two, data one, the RMSE is equal to 12.28. And the RMSE for the case that we just use a simple regression for the both data, it is equal to 13.82. It's interesting, isn't it? When we are using some nonlinear structure and estimator to come up with results in such an uncertain environment in subsurface engineering, we are we are biasing to something non-linear. And in engineering world, as long as we are faring away from a linear estimations or linear approach in engineering world, and especially when we are working in a very uncertain environment, as long as we go away from a linear approach, we are in risk. We are especially in risk. Machine learning is what makes the hardware smart. As a conclusion, I want to note something important to you guys. ANN does not make the hardware smart, so it's not an intelligent system. We cannot claim that we have developed an intelligent system using ANN. You can find many journal papers that claim that, and it's wrong. ANN is not a good predictor in subsurface engineering. Geostatistics is something more relevant. You know, the big guys in geostatistics, for example, Clayton Deutsch, Jeff Kears, Javier Emery, they obviously know that something like machine learning or neural network is existed. So just think why they are working on geostatistics. Obviously, geostatistics, because geostatistics can involve the distance and the model of heterogeneity between the wells and in all the reservoir. So it's clearly obvious that we have to use the geostatistics for the predictor, not a a non-relevant and non-linear tool to be used in subsurface engineering. Computer science and geoscience worlds are very, very different. Based on my experience, I've worked in uh, different areas. I worked with computer science community databases. I worked with their signals, and also I worked with the signals and databases obtained in from subsurface. I worked with two types, and these databases are not similar together even 1%. Intelligent algorithms that can work in computer science community, they cannot be used in geosciences. You have to modify them. In these 10 years, I couldn't use any computer science algorithm, the algorithm that developed in computer science community, without any modification in geosciences. In my 10 years experiences, I didn't see any, even one single case. Okay. ANN is useful as long as being used as a classifier in subsurface engineering. If you want to classify something, you can use ANN, but as a predictor, it's not a reliable thing. In engineering world, standing on nonlinear predictor is very risky and dangerous. Really, it's very risky. I strongly recommend do not deviate from linearity in environments that you have a huge amount of uncertainty, like subsurface engineering. You guys just can test my descriptions here in your work. If you use neural network as a predictor, you just can try another simple regressions, and you can find that there is no obvious, and big differences between in the results. And just if you want published papers, it works. Okay, yeah, in academic world it works, but if you are moving to the industry, you cannot rely on something that you do not have any idea how it's working, why and why it was developed. Artificial neural network was not developed for being used in subsurface engineering. And thank you so much for your time. And please leave a message or comment below the link, and you guys can just follow the iPetrol link and the channel in YouTube. It would be appreciated. Thank you guys. Bye.